So today we're going to talk, today's date, 11/15/17. So today's topic, we're still going to be solving quadratics, but we're going to do it from vertex form, okay? You ready?
Yeah, I'm ready.
Thank you. Okay, so vertex form we learned the other day was when we had the x plus something quantity squared, right? That was vertex form, okay? So what we want to do is this. There's two ways to do number one. One is by factoring. Factorings are great, but I'm going to show you both ways, okay? Before we even start, we know that all of these are going to have two answers. Anytime you have an x squared, you're always going to have two answers. Now, in example one, if I factor it and go x plus 3, x minus 3, okay, it'll factor, right? It equals 0. We get two little mini equations. We get x plus 3 equals 0 and x minus 3 equals 0, right? So we factor it, make our little mini equations, solve, we get x equals negative 3,
Can you
and
just
x equals...
just change it to that because you already know it's going to be the opposite?
Yes, but you have to be careful, okay?
Let's not say the
Okay,
opposite.
so now, there's another way to do this, okay? The other way to do this is to solve it. If you don't have to factor it, sometimes you can solve. So what we know is we know the square root of 9. We know the square root of 9 is 3, right? Oh, you guys, I'm just tired of this, okay? You know, we got to pay attention, honestly, okay?
Yeah.
So I'm tired of it. I'm trying to teach. You got to pay attention, okay? Next time, just go outside, right? Okay? Going to go outside, right? Because we're going to pay attention. Now, we're not going to say, I don't get this, Mr. Davies. Well, I understand why you don't get it. You got to pay attention, all right? So now, let's keep going, all right? I'm tired of this. Just stop talking. Pay attention. All right? Now, so we can solve this one by factoring. That's one way. The other way to do it is you could actually go and solve it. When you go ahead and solve it, you can bring over the 9. You can have x squared equals 9. And then in order to solve it, the opposite of a square, to undo a square, would be to take a square root. And of course, we all know the square root of 9 is 3. That's another way to do it. And this works only if you don't have to factor. Only works if you don't have to factor. So we know the square root of 9 is 3, but so is negative 3, because we know that negative 3 times negative 3 is also a positive 9. You need two answers. So we know that negative 3 and 3 work. So we can write this as plus or minus 3, which shows both answers. Okay, one more time. Another way to do this, and I'll show it on a separate sheet, okay, is I could bring over the 9. So if you don't need to factor it, you can just solve it. I can have an x squared equals 9, okay? So if you don't need to factor it, you can just solve it. Bring over the 9. The opposite of a square is a square root. And we know the square root of 9 is 3. But we know we need two answers, right? And since we need two answers, we know that there's also a negative 3, because we know negative 3 times negative 3 is also a positive 9. So we get 3 and we get negative 3. Now, a fast and easy way to write that, shorthand, would be plus or minus 3, which represents both answers, okay? So by putting plus or minus like that, 3, it shows 3 is an answer, and so is negative 3, okay? Now, example 2 is a little bit different, okay? In example 2, we're going to have to do a little bit of solving after we square root it. So we're still going to solve it. We still need to get rid of the square. So to solve, you always do the opposite, and the opposite of the square is to square root it, okay? So the square will cancel the square root, okay? So the square is gone from the square root, and I'm just left with an x plus 1 equals, well, the square root of 9 is 3. But we learned over here that it's actually going to be plus or minus 3. So when we take the square root of 9, if we have an x squared, we know it has to be two answers, so it's plus or minus 3. You have to have the plus or minus 3 because we need two answers, right? But we still now have our little, we have a mini equation. We do have a mini equation because one equation is an x plus 1 equals 3. And the other mini equation is x plus 1 equals negative 3. Okay, so you set it up to, since it doesn't equal 0 this time, but it equals plus or minus 3, so you set your x plus 1 equal to 3, and your x plus 1 equals a negative 3, okay? Alright, Cole, you had a question?
No, I'm good.
You good? Okay, now let's solve our little mini equation. So we're going to go minus 1, minus 1. One answer is 2, and the other answer is minus 1, minus 1. The other answer is negative 4. Well, if you take a look at it, in fact, you might have been able to just do this in your head, right? Because you know, if you take a look at the original problem, you know if 2 plus 1 is 3, 3 squared is 9, right? And if you put in the negative 4 plus 1 is a negative 3, but negative 3 squared is a positive 9 also. Okay, so sometimes you can do a little bit of it in your head, okay? Okay, example 3, same type of problem, but let's bring over the 36 first. So we bring over 36, because we need to set it up like we did example 2. So bring over 36, so I'll add the 36. I'll go x minus 5 squared equals 36. Okay, so I added the 36. So plus 36, okay. Again, I'm solving an equation, so I need to get rid of the square by taking the square root of it, because the square root will cancel the square root this. So the square root cancels the square. We're left with just x minus 5 equals, and the square root of 36 is 6, but also negative 6, because again we need two answers. So we're going to say plus or minus 6. It's going to be a 6, and it's going to be a negative 6, okay? Now we get two little mini equations, right? So the mini equations, so my little mini equations are going to be an x minus 5 equals a 6, and an x minus 5 equals a negative 6, okay? So the difference is it doesn't equal 0, like if we factored it. It just equals whatever the square root was, right? Okay, and I'm going to solve. I'm going to go plus 5. One answer is 11. I'm going to go plus 5. One answer is negative 1, okay? Always two answers. Okay, okay, example 4. Same type of problem, exact same type of problem. It's just going to take a couple of extra steps to get it there, okay? So I'm going to bring over the 50, and then I'll divide by 2. Okay, so let's bring over the 50. How do I bring the 50 over? I add it, right? So I'm going to go 2 parentheses x plus 4 squared equals 50. Don't distribute. Don't do this. Don't do this. Don't do that at all. Don't do that. Don't do that because it's quantity squared, right? So don't do that. But what we can do is just divide out the 2. Just divide by 2 both sides. Divide by 2, divide by 2. That gets rid of the 2, doesn't it? So we're going to divide by 2. We're going to divide by 2, and I've got a x plus 4 quantity squared equals 25. And now it's just like the others, isn't it? It's just like this. So I divide it by 2, divided by 2. I get 20, and then I'm going to square root it, yeah. So now I square root it, get rid of the square root it. Has to be two answers. So I'm going to have an x plus 4 equals plus or minus 5, right? Yeah. So I'm going to go, okay, x plus 4 equals 5, and x plus 4 equals negative 5, right? Minus 4, one answer is 1. Minus 4, the other answer is negative 9, okay? Thumbs up so far? Okay. These are actually pretty easy. They're easier than, say, example 5. Because example 5, you have to know how to factor. However, if you're good at factoring, then maybe example 5 is easier than the others. Can you factor? Well, if you can factor. Now, how do I know I have to factor this one versus these? What makes example 5 different than these?
There's more x's.
There's more x's, yes. There's no quantity square thingy, right? So let's just factor, right? This one we will factor. It's different, isn't it? So I factor, I go x, right? Minus 6 plus 5. Our mini equations, right? I'll have an x minus 6 equals 0. And I'll have a x plus 5 equals 0, right? I'll solve my mini equations. Plus 6 plus 6. One answer is 6. Or like Isaac said, just the opposite. And Nikolai, you were right when you said just the opposites, right? And x equals -5, right? Totally right. Okay, thumbs up on that one. So sometimes we have to factor, right? And sometimes if it's in this parentheses squared, we'll just square root it, okay? Now, example 6 is the one you guys always forget. We're going to, nice job, Austin. We're going to common factor. Totally right. Good job. We're going to common factor. They have a common multiple of 4. They also have a x in common, right? So I common factor out what they have in common. And then what will be left over, if I factor out of 4x, I'll be left with an x. 4 goes into 8 2 times. Okay? I still have 2 mini equations. Now, yeah, Ellie?
Wait, can you divide it by 4?
Yes. Absolutely. And Ellie, I'm not going to go there, but yes, nice job, okay? Yeah, Julia?
I'm so confused on how you can tell whether or not you have to
Right.
factor it or you have to factor
Okay, 2 terms, and they both have x's. That's one of the
it.
ways.
So if it's like, if there's anything in common, just do that.
Yes, that's a better answer. What you said is much better, okay? So now, we get our mini equations, right? So look at our mini equations. We'll still have a 4x equals 0 and an x minus 2 equals 0, right? And some kids kind of get bothered by this, but you guys don't, because you know that 0 is an answer. 0 is a number, so if I divide by 4, x equals 0. Plus 2, x equals 2, okay? Now, not only that, but think it through. If x were 0, wouldn't it make it 0? Right? And you can see that. If x were 0, it'd make it 0 anyway, right? So 0 has to be an answer, okay? How am I doing? Thumbs up? Okay, we're being quiet. We're learning better, okay? I will state this for the record. When you're screwing around, you're talking, and you're blah, 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 not only are you not paying attention, but all the kids around you aren't, okay? So kids don't learn when you are blah, blah, blah while I'm trying to teach, okay? Turn the page. All right, so example 7. Okay, this is graph. So find x-intercepts by solving. So first of all, one of the things we do know in graphing, this is in vertex form, okay? I know that we're going to use the opposite. Remember that? We use the opposite of that. So my vertex right at the bat in this graph is going to be -1, -9, okay? -1, -1, 2, 3, 4, 5, 6, 7, 8, 9. There it is, okay? -1, -9. Got it right there, okay? Now, we also want to find the x-intercepts. Now, we could do it by our 1, 1, 2, 2, 3, 9, right? But I want to do it the other way, okay? I do know the x-intercepts is where y is 0. The x-intercepts is where y is 0. So let's set y equals 0. Remember, f of x and y are the same thing, right? So if I go 0 equals parentheses x plus 1. Great question. Let me draw a little picture, okay? So, Ben, the problem looks, it's going to look like this, something like that, right? At this spot right here and here, what's the y value?
Oh.
Right? Right? So, let's do it algebraically instead of our 1, 1, 2, 2. Let's just set it equal to 0. So we set the y equal to 0. And let's solve, okay? So plus 9, bring the 9 over, equals a parentheses x plus 1 squared, right? Square root, right? Square root. 2 answers, right? 2 answers. Plus or minus 3 equals x plus 1. Mm-hmm.
Wait,
Yep.
why did we get rid of the 2?
Because you're doing the opposite of
Oh,
squaring it. You're
the square?
Yeah.
Let's turn the page. What did we do to get rid of the square right here?
We just didn't use it after we square rooted it.
Right, because the square and the square root are opposite of each other and they cancel each other out.
Okay.
Okay? Same reason, Zoe. The square root will cancel the square.
Okay.
It's like it's opposite, okay? So then I've got 3 equals x plus 1 and negative 3 equals x plus 1, right? And if I solve, Isaac already said it, 2, and Isaac already said the other, and that was -4, right? So we've got an x-intercept at 2, 0, and at -4, 0. 1, 2, 3, 4, and the y-intercept is at,
0, 8.
and how'd you know that? You're right. It is 1, 1. We know it's 1, 1, but another way we could do it, Isaac, if we want to do the y-intercept, which I wanted to show algebraically, the y-intercept is when x equals 0, okay? So the y-intercept is when x equals 0. So let's plug 0 in for x, all right? I can do that. I can say, all right, y equals 0 plus 1 squared minus 9, and guess what you get? -8, don't you?
You just found that it was -1, -9, and known it would have been the third point over to the left
Mm-hmm.
or the right.
Yes, 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 totally right. So, let me real quickly summarize, okay? So at this point, we've got lots of different ways to graph parabolas, right? And I think your favorite way is the 1, 1, 2, 4, and it works, and the 3, 9, right? And the reason it works is because there's a 1 right here, so it allows us to do the regular parabola, okay? I wanted to show you how the actual algebra will work, okay? Because sometimes that won't work and you have to have another technique, okay? The other technique is if you want x-intercepts, let y equal 0. If you want y-intercepts, you let x equal 0. Now, however, your 1, 1, 2, 4, 3, 9 worked great, didn't it, right? Then we get in Algebra 2, we'll start looking at the harder ones, right? Okay, all right, and we're going to get there some